Okay, on this problem, we have a 10 kilogram iron ball. It's going to be dropped onto a pavement from a height of 1.0 times 10 to the second meters. If half of the heat generated goes into warming the ball, find the temperature increase of the ball. So we are looking ultimately for change in temperature. Now this one is slightly different from the ones that you've probably been working on because we have to start first by using a formula for potential energy that we've had previously, because we need to figure out how many joules of potential energy does this ball have and then use that to transfer over into the heat energy. So if you remember from previously, potential energy is mass times the acceleration due to gravity times height. So in this case, and we also need to make sure that we have our values in kilograms and meters, which we do have. So our mass is 10 kilograms. Gravity, you can either use 9.8 or 10. I'm going to go ahead and use 10 meters per second squared. And then my height is 100 meters. Multiply all those together, and we get a potential energy of 10,000. Now our label is a kilogram meter squared per second squared, which is a joule. Now it tells us up here that half of that energy is going to be go towards warming up the ball. So instead of the 10,000 joules, we're going to be using 5,000 joules is our amount of energy. That is our Q. So now when we go into our formula for heat energy, we're still going to be using Q equals mc delta T. And we know that we have 5,000 joules. We know that our mass is 10 kilograms. We know that our specific heat is 450 joules per kilogram degrees Celsius. And then our change in temperature is what we are going to end up finding, which will be in degrees Celsius. So our kilograms cancel, our kilograms cancel. I am going to go ahead and multiply those two values together, and that's going to give me 4,500. And that would technically be joules per C. I still have my delta T over here, which is what I'm trying to find. 5,000 joules. Now, when I divide by the 4,500, because it's being multiplied by the temperature, I need to use the inverse to get rid of it. I end up, let me get that typed in my calculator here. I end up getting 1.1 repeating. The joules label will cancel out. I'm left with degrees Celsius. That's equal to my change in temperature because those cancel out over there. I need to go back and check my significant figures. Let's see. And it looks like we only get one. Okay, and it wants us to find the temperature increase of the ball, so we can just leave it at 1 degree Celsius is how much the temperature of the ball will increase.